First place to start here ultimately is monitoring. You cannot have a distributed architecture without good observability, without good monitoring in place. These systems are difficult to reason about. In the old days, we could just put in a breakpoint, we'd hit the breakpoint, walk our way through the code, and away we go. And now we can't do that. My application is probably made up of 8, 10, 20 services. I may not have control over several of them. I need to know how calls move through this set of services instead of just what happened inside my code. Now, there's 4 primary components to monitoring. There's logging. What would you say my service is actually doing? Now, you should log anything that's useful as long as it is not personally identifiable information. We actually talked about that at the beginning of the day. Don't put any personally identifiable information into the chat. You should never put PII data into your logs ever. One of the really interesting aspects of PII is some things on their own are not personally identifiable, but if you combine it with 1 or 2 other things, it now becomes personally identifiable. So we need to be very cautious there. Now, I will say in my general experience in software, our logs were one of 2 things. There was like nothing, and we had no idea what was happening, or everything was logged like 45 times, and so it became really hard to know where did this actually start? Because especially in Java applications, it was so common to catch it, log it, throw it, 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 and next thing you know, you're finally at the top of the stack trace. Speaking of which, it can be difficult to trace your way through code because I can't just put in a breakpoint anymore. I actually have to try to figure out how did this call work between multiple different services, multiple different areas of the company, or third-party dependencies. Correlation IDs are your friend here. Now, one of the things that we can leverage is Spring Cloud Sleuth. Spring Cloud Sleuth gives you this auto configuration for distributed tracing. So it'll give you spans, it will give you key value pairs, it will go ahead and put trace and span IDs on the stock ingress and egress points, as well as instrumenting those common ingress and egress points. This is going to give you Zipkin compatible traces. And one of the things I really appreciate about so much of the way Spring works is you essentially add Sleuth to your class path and away you go. So all you're doing ultimately is adding something to your class path, and now you basically have it and you can leverage it. We do need dashboards. This is a way of getting a view into the health of our services. Now, this is just like your car will give you little warning lights when something isn't quite up to snuff. It's the same thing here. We want any interesting metrics to be displayed on a dashboard of some sort or another. But certain events will cause an alert to happen. So if things start to get out of band, we're going to do an actual alert to a human being. Alerting is a super interesting concept. We could probably spend an hour just talking about alerts. What this boils down to is some key metric that we identified for application isn't where we want it to be. The goal in all of these instances is to detect an issue and fix it before the customers even become aware it's a problem, or at least so that it doesn't get to the point where everybody notices there's an issue. That does imply there's a certain amount of pager duty with these applications, and one of the challenges that some companies face is how do you set up pager duty so that it can be sustainable? And the other piece of this is you've got to make sure that you've got clear, concise documentation for people who are on call. Make no assumptions about what people know or don't know. Write it out. Even something that's like so obvious, everybody knows how to do this, write it out. Because at 3 a.m, you're not thinking straight, and it certainly helps to have that extra little bit of information there. This is one of my all-time favorite quotes. We do not rise to the level of our expectations. We fall to the level of our training. In a stressful situation, you are going to fall back on your habits. You're going to panic. You're not going to see the big picture. Make sure you've got good documentation in place for folks, because it's a very stressful situation to be, especially late at night or early in the morning when, oh my gosh, the app is down, we're losing lots of money, get it up, get it working right away. We do need to spend some time thinking about what we should monitor. For our application, what's important? It's not going to be the same from one application to another. Certain things may carry across, others not so much. Some of the things that we're interested in really are just about the infrastructure itself. So that could be things like CPU utilization, RAM utilization, database connections, etc. That's not just going to impact our service, it's going to impact others as well. Others are specific to what we're trying to do with our application, our services, things like availability, latency, response time, etc. This is typically things we identified early in the project as a service level objective, something that matters for us that we really want to keep on top of. We also need to monitor errors and exceptions so that we know if we're seeing a change here. And a lot of what we're looking at is trends over time. Are we getting better or worse over time? And what might that tell us about how our application is behaving, responding, etc.? Now, one of the things that we need to do in this scenario as well is identify this is normal for us. This is things are starting to go a little wonky, and this is critical. I remember once I was driving along and my car had a warning light show up, and I wasn't quite sure what to do at the time. I was young. I didn't know what I was doing, I guess. And so I actually called the service shop and I said, hey, this light just appeared on my car. What am I supposed to do? And they said, oh, that's not a big deal. We'll schedule some time with you. I'm saying, I don't need to come in right now. They're like, no, if it's not flashing, we're good. If it's flashing, you need to pull over because something is going really bad with your car. It's way too hot, or you're out of oil, or something important for a car. It's kind of the same thing when it comes to temperature. There's a normal temperature for us as human beings. I can't think in Celsius. I apologize, but 97 something is okay. And if low grade fever might be something up to 100 or so, and then above that, you've got a fever if it's 101, 102. Although I actually had this conversation with my son's doctor once. I always had in my head that 104 fever was concerning, and she's like, nah, that's pretty normal. Of course, it is interesting to me how doctors have a different concept of severe or mild. There's a lot of talk during the pandemic about mild cases of COVID. And what I came to realize is that when I think of mild, I think of oh yeah, I guess I was feeling a little tired yesterday. Or my nose was a little runny yesterday. That's what I think of as mild. A doctor, it's mostly it didn't kill you, so it's mild. Oh, okay, cool. Now, I want to tell you, this is hard stuff to figure out. You might need a certain amount of history in order to figure this out. I'm convinced this is why a lot of organizations are investing heavily in site reliability engineering, because it helps to have a group of people that live, think, and breathe this day in, day out. Obviously, we want to monitor prod. We also need to monitor our lower regions just so we validate those monitors and make sure that we're seeing what we think we're seeing, understand how to read them, etc. Any metric that we care about should be displayed on some kind of a dashboard. And then again, a human being should be alerted when things start to go out of band. I don't want human beings staring at dashboards all day trying to interpret what goes on. That does not work well. Jakob and I both spent a lot of time going through airports, and one of the joys of that, of course, is putting your bag through the x-ray machine. You'll notice that most airports rotate those people through very quickly. You're not sitting on the line very long, and that's because if you stare at things long enough, your brain just starts to ignore all of it, because 99.9% of the time, nobody's putting anything in their bag they're not supposed to. Most people are good enough to leave contraband at home. Although it amazes me how often people travel with something that they know shouldn't be brought into an airplane, and I forgot that was in my bag. I've done it with a water bottle. That's the most common thing for me. I get a water bottle, somewhere, and I throw it in my bag, and I forget about it, and then they notice it, of course, when I go through security. So I don't want someone staring at dashboards. So if something does go out of normal range, and it's something that I really want somebody to worry about, then that's going to be an alert. Alerts are hard. You can easily over alert. You got to try to find Goldilocks there. Absence of something important can also be an alertable offense. Alerts are supposed to be actionable. They should spring someone into action. It should be urgent. It should be something that needs to be fixed soon, not something, we can take care of that tomorrow or later this week. It also should require a human to actually do the work. If the system can just make itself right, that's not an alert. That's maybe a monitor. That's maybe something that gets dumped out on a report. But let the system fix itself. Again, I think this is why we talk so much about SRE over the last few years. I really recommend that you become familiar with this book. You don't have to read it cover to cover. It's just a group of essays that are sort of loosely bound together. One of the things that comes out of the SRE book is the 4 golden signals. So latency, how long does it take to service a request? What is the traffic demand on my system? How many requests per second IO rate, etc.? What is my failure rate? And that can be an explicit failure, an implicit failure, a policy failure. And then saturation, how much of some constrained resource do I have left? We do need to consider sampling frequency. Now, I know it is popular to keep adding more Ks onto things. You know, I'm old enough to remember standard def TV. I was actually watching something with my son, and he sort of looked at it, and he looked at me, and he said, how come there's black bars on the side? And it took me a while to go, oh, yeah, sorry, dude, that's 4:3. That's not the 16:9 you're used to. And he just didn't comprehend. I said, yeah, things used to be standard definition. And, of course, now everything's high definition, and it's 4K and 8K and all the Ks. You know, I remember when the iPod was sort of the dominant music device back before it all just became a feature of our phones, basically. Somebody came out with a new iPod competitor, and my only real memory of it is that it was shaped like a Toblerone bar, which, while striking and interesting looking, I thought, boy, that's not going to be the kind of thing you're just going to slide into a pocket, is it? It's kind of unwieldy and gangly, but okay, some marketing person thought it was a good idea. But its whole claim to fame was it's higher resolution. It's a higher sampling rate than the standard whatever it was on iPods at the time. And so they were all bragging about how rich the music was and how deep, and it was so beautiful, and you could tell a difference. And then, of course, what they neglected to tell you is just how much space those songs took up compared to the way the iPod did it. And, of course, audiologists were quick to point out, yeah, you can't actually tell the difference, sorry. So high resolution, while it may be tempting, is rarely our best plan. You know, generally we want to find, again, Goldilocks, what's kind of that right mix of not too much but not too little. We typically want to aggregate data in some way, shape, or form, and there are so many good tools out there. But I always like to remind people of what we can do with Spring Boot actuators. So there's an awful lot of stuff that's right on actuator that we get right out of the box. And fingers crossed that our technical issues are resolved. I'm going to try to hand it over to Jakob, and we're going to see what kind of trouble that gets us into.
Cool. So I'm having some connection troubles. Hopefully it's solved right now, but fingers crossed. Right, I picked one sentence, at least one sentence from what you were saying, Nate. At 3 a.m., you are not thinking straight. You said something like that. It has never sounded so right to me. It has never sounded so right to me. It's 2:30 right now. So I am not thinking straight, but I don't have to, because I have Spring and I don't want to reinvent the wheel. I want to use the powers of default. And it was already mentioned that when I want something in Spring ecosystem, I need to add it to my class path. Of course, it's not only important to add it to the class path, because it's important to understand, not to memorize how to do things. So let's try to understand what's happening underneath when I add actuator to my class path and Spring Boot Starter Web. So actuator brings production-ready monitoring features to our application. In other words, gathering metrics becomes very trivial right now. Of course, we get it without having to actually implement anything ourselves. And actuator, or actuator, I always forget, sorry Nate, you'll have to correct me on that. I guess actuator. Actuator is mainly used to expose information about the running application. So like health check, information about like metadata of the project, thread tab, etc. We'll see those in a while. And it uses either HTTP endpoints or JMX pins or both to enable us to interact with it. Which means that's why I added Spring Boot Starter Web, which brings me embedded container so that I can expose our metrics via HTTP endpoints. So just thanks to those two dependencies on my class path, I can run the application right now. And as soon as it starts, I will be able to go to HTTP 8080 because that's the default port if my memory serves me well today. and do HTTP localhost 8080/actuator, which is the default path, and do a bunch of things by default. Let's see. So our application started on 8080 on Tomcat. That's the default embedded container that is brought by Spring Boot when we chose Spring Boot Starter Web. And now let's do this. Maybe I will go to my browser because this terminal won't give me readable data. I will do localhost 8080 actuator/loggers, for instance. As you can see, I can see all of the loggers with the effective and configured levels. So that's HTTP GET. If I do HTTP POST, I can change one of the levels so that I can debug something, for instance. So that's only one of the endpoints. If I go to /actuator again, that's the default endpoint that you can change to something else. I will see the list of every endpoint, every metric that is brought by default by actuator. Like what kind of circuit breakers we have. We will be talking about circuit breakers soon. What kind of beans I have, what kind of caches. I can do the health check. As you can see, the application is up. I can get some information. They are not configured, so the information data is empty. I can go and take a look at the mappings, so all of the HTTP mappings that the application provides. I can go and do, for instance, as I think something like environment. Yes, so probably not so secure to take a look at this, like without any kind of authorization. If you think that, you are right. But for the sake of this demo, I just disable the security. By default, it's enabled, of course, so Spring Actuator integrate to Spring Security. So whoever is authorized to see that will be able to see that. Whoever is not, they will not see those endpoints. The second endpoint means that all of the endpoints provided, the second property says that every endpoint provided by Actuator is by default included and exposed. Some of them are not exposed by default. By specifying this, I have exposed them all at once. So it might be that all of the endpoints that you are seeing right here, not right here, but right here, it's not enough. Maybe you need something more. By the way, remember, HTTP is one of the ways to serve the information. The other way is via JMX. But if there's something more specific to your project, to your product that you need to expose via JMX or via HTTP or both, Spring Actuator brings you the ability to create your custom endpoints. Let us try to create a custom endpoint. So when you want a custom endpoint, you need to use annotation called @endpoint. Maybe you want just web endpoint, and that would be web endpoint, or maybe just JMX endpoint, that would be JMX endpoint, respectively. Of course, if you want both, let's say we want to both, I would choose @endpoint. And if I pass ID here, that's the name of the endpoint, which means I will be able to access this information, the information we are going to provide. So that will be, by the way, a random number, not very useful, maybe information about our application. I can access that at /actuator/random. All right, that would be a Spring Bean as well. And I will call this class custom endpoint. And I mentioned that you are able to both read the information and write the information if I use annotation called read. This will be invoked whenever I hit HTTP get random, like this. Return new random next int. If I use write operation, not web endpoint but write operation, I will be able to change whatever I would like to change. In this case, I don't have nothing to change. Maybe a seed for the random generator, I don't know. But I can use write operation to use to use HTTP post to change the information, or JMX bean to also write information to our applications. It's both read and write. All right, so add endpoint. That's the name of the endpoint. Service, custom endpoint, read operation sounds okay. Looks okay. Let me rerun the application, and we will hit localhost 8080/actuator/random, and I hope to see random numbers. Let me try to do it. Clear HTTP curl localhost 8080/actuator/random. As you can see, I'm seeing random numbers. Maybe that's not the best metric that I can gather thanks to my application, but you can choose whatever you want. You can pick whatever you want to here. Maybe whatever Spring Actuator provides is not enough for you, but we got you covered. You can create custom endpoints. By the way, Nate, do you know what an actuator is, like outside of IT? I think I have asked you this question one time, but I don't remember the answer.
So my rough understanding, and I'm going off of this conversation I remember us having. Again, I just want to stress, if you have questions for us, please do ask. We're here to serve, so please throw things at us. Believe me, we have plenty of material, but I'm much more interested in issues that you all might be running into, or things that you're curious about, or things you always wondered about. So, take advantage of the fact that we're here live. If we don't know the answer, we'll try to find it for you. So the moral of the story, like so much in software, we just can't have hand-rolled solutions. That way lies madness. So many of the things that we're talking about today, when these patterns, concepts, tools first came into being, it really was up to each project to build their own. That's not sustainable, and that's certainly not what we want today. I don't want my projects all doing their own thing here. One of those challenges that we certainly face in a lot of enterprises is the reality that I just can't have there be 1,000 ways to do something. There needs to be some amount of consistency, and we just need there to be. We can't afford for it to be all whatever you feel like doing. So take advantage of the fact that many of these things are built in and they are there for you to use. There are a number of excellent endpoints that give you all the basic stuff you would expect. And as Jakob just showed you, you can absolutely create your own. Now, I do want to stress that monitoring is something that takes time. You're not going to get this right the first day. It's going to take some effort. Again, I think this is why there's so much talk around SRE these days. I also want to stress that just because something is easy to measure does not mean it's actually something that's helpful to us. I think about lines of code in this regard. It's too often in my career I've had people try to measure us based on lines of code, and it's so silly. Although it is something that's easy enough to game, so fine, if you really want to measure me that way, I can totally make that work. We also need to understand the business drivers. This is one of those things I spend a lot of time talking to my grad students about, is that you need to be able to map the business drivers, the business change, how the business works too, and that's how this affects your services. It isn't enough just to think about the technology. We have to go deeper than that. We need to understand that, well, if we get a whole bunch of orders or a whole bunch of customers or a whole bunch of signups, or everybody wants to watch that show right now, what does that do to us? And how does that translate down to these individual services? I think it's pretty remarkable how far we've come, frankly, with streaming services. It wasn't all that long ago that just the idea of streaming a TV show, a movie, whatever, was just like mind blown. And then we'd get kind of grumpy when it was Game of Thrones was the first place I really remember this happening. It'd be a new episode of Game of Thrones, and millions of people would be hammering on HBO's site and on their app, like, well, I want to watch it right now, and it would crash. It reminds me a bit of the fail whale from back in the day, and how rarely we see those things. It's almost quaint when things don't work, which is a testament to just the engineering effort and discipline that's gone into making these services so reliable. And a lot of that is due to the things that we're talking about here with you tonight. Please be realistic. I run into this a lot. Every business person I meet is so optimistic, and we're a rocket ship going to Mars. Like, are you sure about that? I'm sorry, friends, we can't all be a third of internet traffic. That's just the nature of the beast. All right, so one of the things that we've tried to do throughout this presentation is provide you links to more. So if you see something, and obviously we're not going deep dive into any one thing, we're trying to give you a survey of the landscape, kind of point out some interesting shells along the way, and hopefully that will spur some interest for you that you might want to then learn more about something, and we've tried as much as possible to give you links to that. So unsurprisingly, there are videos, there are blog posts, there are tutorials, etc. There's an awful lot in this space. Now that takes us to fault tolerance. One of the realities of distributed systems is that they are not, in fact, islands unto themselves. That's kind of the point. When you start building these distributed systems, your services will fail. None of us can build a service that has zero downtime. You know, if you ask a customer how much downtime can you tolerate, they're going to say 0. It's like, yeah, that's not realistic. We're human beings. You know, there's on a semi-regular basis, although it is a lot rarer than I would have expected. You know, you read about US East 1 goes down or Cloudflare goes down or something like that and takes a third or more of the internet with it. Failures find a way. Now, it's tempting for us to try to shift blame to someone else and say, oh, it's not our fault, it's our cloud provider. Oh, it's not our fault, it's our edge caching service. Customers don't care. They really don't care. At the end of the day, they just want their application to work, and they're going to hold us accountable for it. Here's the reality. You can't prevent all bad things from happening, but you can be prepared to deal with it when it does happen. This is one of those things as a parent I think a lot about. I cannot possibly prepare my son for every single scenario out there. You know, I can't prevent every bad thing from happening. Hopefully, I've given him the tools to deal with the inevitable unknown that he's going to encounter in his life. So you know you can't prevent all bad things from happening, but we need to be prepared to react in some way, shape, or form. Now, what should that reaction be? Should it just be a default error message? Should I have some backup service? Should I have cached some data? Do I just return a default answer? I learned a long time ago in computer science, there's 3 answers that work for every question. There's 42. That's the geek check to see who's well read. There's another layer of abstraction. That's my favorite pattern as an architect. But the answer I have to give more often than not is, it depends. Now, I never mean it depends as a way of ending the conversation. It's the beginning of the conversation. And anytime someone says it depends, the next word out of your mouth should be, what does it depend on? And we should be willing to have that conversation. We need more information. So if you think about your services, some services are more equal than others. Some are more important than others. You know, if we look at like a retail site, like an Amazon, a Best Buy, something like that, the ability to add an item to the cart and then to check out, take my money, that's got to work. That just has to work. And if the people who bought this also bought that kind of recommendation thing's a little out of date, that's probably not mission critical. If the reviews, if I'm not seeing like the latest reviews, that's probably not the end of the world. You know, so different parts of that application, that website, are going to have different needs. And it's important for us to look at those needs realistically and understand which ones of these are going to need a different response if something goes south, because it will happen. And that's where we get into the circuit breaker. Now, this is not a new pattern. This has been around for quite a while. This was originally described by Michael Nygaard in his Watershed book. And here's the basic gist of it. When everything's going according to plan, the circuit is closed. This always takes me a little bit of time to get my head wrapped around. It works just like the circuit breaker in your house or your apartment. If everything's good, the circuit's closed, the call passes through to the normal situation. If there's enough errors, and you can configure what that is, the circuit is opened, preventing the call from going through. There's no reason in us continuing to make this call if it keeps failing. It's just like if there's a power surge, your circuit breaker opens up, preventing that power surge from frying all the circuits in your house, right? So that's the idea. Closed, everything is good. Open, we got a problem. Now, eventually, this is one of the nice things about software, is it can monitor itself and see that, everything's kind of back to normal now. We're going to go ahead and close the circuit again. Yeah, it doesn't happen in your house. Your house, you got to go down, find your breaker panel, flip it over yourself. It's good times. Moral of the story. We wrap some critical call, some vulnerable call in a circuit breaker. The circuit breaker watches what happens, and if a failure threshold is exceeded, opens up the circuit, redirecting to whatever fallback mechanism we have defined. And that's completely up to us. Again, that could be a default answer, that could be an error message, that could be redirecting to another service. It just depends, again, on the criticality and what is the consequence of this particular thing not working. It sort of pings that existing call to see, are you healthy now? If you are, okay, cool, we can go back to the way things were before. Now, when Michael first talked about this, you had to build your own. There were no libraries to do it. There are multiple implementations now. Again, one of the things I love about Spring Cloud and Spring in general is it gives me this abstraction layer on top of these things so that I can code that abstraction layer, and if I need or want to change the underlying implementation later, I'm free to do that. So this gives us a consistent API, allowing developers to pick the implementation that makes sense to them, whether it's Hystrix, Resilience for J, Spring Retry, etc. We just have to add the proper starter to our class path we call the factory, and now we can inject that circuit breaker wherever we need to inside the code base. I think I'm going to pause here, and I will, fingers crossed, yeah,
Nice.
System works,
Nice.
buddy.
So far, so good. All right, so circuit breaker. Again, if I want to use it in my Spring ecosystem, in my little app, I need to add a dependency. And Nate mentioned a couple of implementations. We are going to use Resilience for J. In my humble opinion, the most popular circuit breaker implementation out there. It used to be Hystrix. It used to be the most popular, but then it went into maintenance mode. And Resilience for J, I think, I cannot stress it enough, I think is currently the most common one. At least I use it most frequently, and that's why I'm choosing this for the sake of this demo. All right, so we'll pick Resilience for J. Let's go back to our application and to our pom.xml. So we started with data JPA with H2, then we added actuator and web to expose some information. By the way, we are going to use the embedded container to have some business HTTP mapping to evaluate risk in our little credit card application. And now I have added also Spring Cloud Starter, Circuit Breaker, Resilience for J, which gives me circuit breaker capabilities in my application. All right, but before introducing the circuit breaker, let's create a simple endpoint. It will be an endpoint that will be evaluating our risk. It will be under get mapping. So, for instance, HTTP get/evaluate. Let's say it will return string for the sake of simplifying this. I will also call it evaluate and will return OK. That's a very, very, very sophisticated risk checking mechanism, right? So in order for me to be able to hit this endpoint right now, I need to add rest controller annotation, which gives me HTTP handling capabilities to that class. So now I'm exposing HTTP get/evaluate, which invokes that code. All right, so let's make it a bit more complex. Let's maybe even make our application talk to a different application, a remote application, or at least let's simulate that we are dealing with a distributed system. So instead of returning OK, we'll be calling a risk service. Okay, maybe risk service is not managed by us. Maybe we have to use it from whatever reason, but we cannot be sure about its performance. Maybe every now and then it down performs. So I will try now to simulate that we have a failing risk client like this. It will be a Spring bin, a failing risk client, and it will have one method /evaluate. And let's first simulate HTTP blocking call. So it takes some time. Maybe it's a slow endpoint. So I will simulate that by sleeping. Don't do it in production. I will sleep for 300 milliseconds, and also this is just a demo. So I will just do try and catch. I know we can handle that in a better way, but this simulates that we are waiting. We are waiting for the remote system to answer that. We don't know the answer yet, by the way. Maybe it will be a failure. Maybe we won't get any useful information. So not only we have waited 300 milliseconds, but you know what? Half of the calls are terminated after that. Maybe there is a network failure. Maybe there is a risk system failure. Whatever. You know what? Let's make it 75%. So only one out of 4 calls will be successful and return okay. So this is a simulation of a system that we depend on, that we rely on, and it's down-performing. It takes a while for us to get an answer. By the way, we are waiting, and most of the times we are getting an exception anyways, like timeout or service unavailable or something like that. All right, so now let's use our failing risk client in our risk controller. So I will inject that in here. Failing risk client, cool. And let's delegate this call to evaluate from failing risk client. Let me run the application right now. And I will hit localhost 8080/evaluate multiple times. I hope to see exceptions like HTTP 500 codes. And I also hope to see maybe one. Okay, let's do it. Curl localhost 8080/evaluate. An error. Okay, there's okay. An error. Okay, so the system works. But let me do something more sophisticated. I will do benchmark with AB tool. So I will use AB, which is Apache benchmarking tool. I will do 100 calls, so -n means 100 calls to HTTP localhost 8080/evaluate and evaluate. That will give me a nice summary of what's happening in our application, because you know what, in the real world, we don't have like 4 calls per day. Probably we'll have multiple simultaneous calls, and all of them will be probably failing. They will wait for one another because we have a limited pool of threads handling our HTTP requests. By the way, I'm doing, because the benchmark is still on, I'm doing 100 calls. Each of them lasts at least 300 milliseconds. So the entire benchmark should take, by the way, it's finished right now, should take at least half a minute. And that's correct. Time taken for the test, 31 seconds. I have 100 complete requests, failed request, 1/5, right? 21. So almost what we expected. Here we have failures, right? Non 200 responses, 79. So almost 8%. We expected 75% non 200 responses. We have 79, more or less fine. As we can see, each of the calls waited at least, each of the connections, each of the clients, we might want to say, waited at least 300 milliseconds to get almost all the time exception. So the basic idea behind the circuit breaker is very simple. We'll wrap this protected call in the circuit breaker object very soon, and it will underneath monitor for failures. And every now and then we'll reach a certain threshold of failures, and the circuit breaker will trip. That means all of the further calls won't go in here. All of the further calls won't go in here, and we won't have to wait 300 milliseconds. Let's do it. So I will inject a circuit breaker factory in here and configure our circuit breaker factory in this constructor, just because I don't want us to jump back and forth between configuration classes and this risk controller class. Normally in production, of course, we wouldn't configure circuit breaker factory in the same place where we have an APV mapping, because that's like against all of the good rules when it comes to separation of concerns. But for the sake of the demo, let's keep it simple. I will have configuration like this. So I need to pass a couple of parameters, like how many failures I want to see so that the circuit breaker trips. How much time do I spend in an open state? Open state is a state where we don't have connection. And how many probes do I try when I'm in the half open state? So half open state means, well, you know what, we are in the open state, but maybe the risk system is up again, so I will try. I'll maybe try to call it once or twice. We have to pass some time configuration as well. Default time in each place, it will be 300 milliseconds. And now I will pick the actual implementation. The actual implementation is resilience for J, config, resilience for J, as you can see here. And I'm passing two above configurations that we have just discussed. All right. So this gives me ability, because now the circuit breaker factory is configured. This gives me ability to create a circuit breaker object like this. Not config, but factory, which is configured right now. I will call our circuit breaker object evaluate and store it as a field in our class. All right, that's better. So now I am finally able to wrap the protected function call in a circuit breaker object like this. Run failing risk client evaluate. Or maybe I want to pass a default answer when circuit breaker is open. So now, of course, this code is somewhere else. The only thing I needed to change is to wrap this into a circuit breaker object. Let me rerun the application. Once it's up, I will try to rerun the benchmark, and this time I suspect the benchmark to take less time, because most of the times we won't be even hitting this, because the circuit breaker probably will be open. All right, let's try AB. And as you can see, it was almost instantaneous. We have 95% of the calls, they lasted less than 4 milliseconds, which means there is no way for them to enter this blocking call. Most of the times we're getting the manual answer. We can even check it. So I have curl localhost 8080 evaluate. As you can see, I'm getting manual as the answer most of the time, which means the circuit breaker is open right now, and we are not connecting, and we are not waiting, we are not saturating the network. Circuit breakers, they help to reduce resources in operations which are, by the way, I would say, likely to fail. We are failing 75 times out of 80 times. Probably we'll be failing one more time when we call. So also, we avoid waiting on timeouts for our clients. We don't make them crazy and mad at us. And we are not putting additional load on an already struggling server. So we have a couple of advantages. We are talking about remote calls all the time, but there's nothing prevent us to wrap any call, like any call which fails. It may be in the same process, but it fails every now and then in a legacy system. We can wrap it into a circuit breaker pattern. So in any situation where we want to protect parts of our system from failures in another part of our system, anywhere. But remote calls are like very obvious to take into account. Needless to say, circuit breakers should be monitored they are very, very valuable places for monitoring. I will even say that most of the changes that happen in circuit breaker state should be at least logged. At least logged. Our circuit breakers should have all of the details of what happened with Linux4j, and circuit breaker abstraction and Spring provide that. We should have some sort of warnings whatever happens if we have some deeper troubles. But all of this is also built in also with dashboards in Spring ecosystem. All right, that's it. Hopefully I'm